Assalamualaikum warahmatullahi wabarakatuh. Hi, my name is AGHNIA binti Muhammad NAZLIN and my matric number is CF210224. I would like to present about the introduction of permeability. What is permeability of the soil? Permeability is a measure of how easily a fluid can flow through a porous medium. In geotechnical engineering, porous medium is soil and fluid is water at ambient temperature. Permeability, also known as hydraulic conductivity. Next, permeability is an essential soil parameter in trenchless construction and general earth construction, which is used to predict soil behavior and is required to design and build several types of structures such as earth dams. Thirdly, the amount, distribution and movement of water in soil and have an important role on the properties and behavior of soil. The engineer should know the principles of fluid flow, as groundwater conditions are frequently encountered on construction projects. And lastly, data from field permeability tests are needed in the design of various civil engineering works. For example, cut-off wall design of earth dams. Next, this figure shows the flow of water through soil, which is lamina and turbulent. Lamina is each fluid particle travels along a definite path, while turbulent paths are irregular and twisting. Next, factors that affect soil permeability. Firstly is particle size. Permeability varies according to the size of soil particle. If the soil is coarse-grained soil, the permeability is more, and if it is fine-grained soils, the permeability is low. This is because coarse-grained soil have large particle size and fine-grained soil have small particle size. Next, soil void ratio. Permeability increases with void ratio, but it is not applicable to all types of soils. For example, clay have a higher void ratio than any other types of soil. Next, specific surface area of particles. Specific surface area of soil particles also affects a permeability. The higher the specific surface area of particles, the lower the permeability. Next, shape of soil particle. Rounded particles have more permeability than angular shape. It is due to the specific surface area of angular particle is more compared to rounded particles. Next is soil structure. Soil structure have two types, which is flocculated and dispersed. If a soil contains flocculated structure, the particles are in random orientation and permeability is more. If the soil structure is dispersed, the particles are face to face, so the permeability is very low. Next, degree of saturation. Partially saturated soil contains air void, which are formed due to entrapped air or gas released from the percolating fluid or water. This air will block the flow path, thereby reducing the permeability. Fully saturated soil is more permeable than partially saturated soil. Next is water properties. Various properties of water or fluid such as unit width and viscosity also affect the permeability. Permeability increases when viscosity decreases. Next, temperature. Temperature also affects the permeability in soils. permeability is inversely proportional to the viscosity of the fluid. It is known that viscosity varies inversely to the temperature. Next, adsorbed water. Adsorbed water is the water layer formed around the soil particle, especially in the case of fine-grained soil. This reduces the size of the void space by about 10%. Hence, permeability reduced. And lastly is organic matter. Presence of organic matter decreases the permeability. This is due to blockage of voids by the organic matter. Importance of soil permeability. First, underground seepage study is an important aspect of all the civil engineering works. Secondly, it aids in the determination of geostatic stresses and the effect of water pressure on earth structures. Next, it gives a beforehand idea about settlement of a foundation and volumetric changes in soil layers when subjected to fluids or water. And lastly, before constructing a structure, it is always helpful to know the amount of water that can be discharged through a soil mass, and calculating permeability is the best way to know the discharge quantity. Properties of soil permeability. First, solving problems involving pumping seepage water from construction excavation. Secondly, estimating the quantity of underground seepage. And lastly, stability analysis of earth structures and earth retaining walls subjected to seepage forces. That's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Syahmi NAZMI bin HISHAM. Matrix number CF21702. Okay, here I will discuss about application of permeability. Okay, what is permeability? Permeability is the ability of a sustain to allow another sustain to pass through it, especially the ability of a porous rock, sediment, or soil to transmit fluid through pore and crack. Okay, the thing very related to the permeability is slope failure. Slope failure is the phenomenon of landslide and relates slope instability in concern in many parts of the world. The significant reduction of magnetic suction causes submersion of soil shear strength. Okay, these are examples of cause of slope failure. Slope failure can be occur by many factors such as gravitational force, swelling and leaching, weathering and erosion, slope angle and rainfall, rapid drawdown, and earthquake force. Okay, what is gravitation force and earthquake force? Gravitation cause of failures slope are an important force that affect the flowing or seeping water as well as stability of large soil mass. Okay, next is swelling and leaching. Highly plastic and over-consolidated clay easily swell when it comes in contact with water. These are the factors controlling time rate of swelling. First, water content. Second, density. And third are soil composition. Other than that, weathering and erosion. Erosion on the surface of a slope may be because of removal of a certain weight of soil. Other than that, erosion may increase the height of the slope or decrease the length of the incipient parallel surface, thus decreasing the stability of the slope. Okay, next, slope angle and rainfallment. Slope angle also has a great impact in the scoring process to run off water. The larger the slope, the larger the runoff transformed by rainwater, which also result in greater erosion effect and the greater the soil loss due to runoff on the slope. Okay, rapid drawdown. Rapid drawdown, what's mean of rapid drawdown? If the water level in the reservoir remain at low level and the failing did not occur under the undrained condition, seepage of groundwater will occur, and the additional seepage force called provoke failure. Okay, these are the steps for the slope protection and surface protection. The purpose of slope stabilization technique is to increase the factor of safety of a slope to a level that is considered adequate. Okay, these are few steps of slope protection. First, bonding a stable soil mantle to stable subsoil or substrata. Second, provide a cover of a laterally strong fibrous system close to the surface or to the slope. And third, implementation of pre-stress anchor, rock boil, pile and soil nailing, geosynthetic reinforcement, retaining wall, shotcrete, and others many more. Okay, what metallic structure? Metallic structure which are anchored to the rock slope help to avoid the deterioration of the slope and the fall of rock on the pavement. It is especially used for step slope. Okay, next is retaining wall. Retaining wall is a strong solid barrier utilized to support soil laterally so as to retain the soil at two separate levels at the border. We can see on the feature there are two levels of slope. Okay, other than that, retaining wall are used to mitigate soil failure and are a favorite form of slope stabilization. Retaining wall also used to separate water from land are called bulkhead. Retaining wall can be seen in many construction because it can provide a slope from landslide.
Hello and Assalamualaikum. My name is MUZHAFAR Izzat bin ABDUL HALIM, matrix number CF210205. So today I want to present about case study, which is our group topic is permeability. So in our report, we took two case study, which is the first one is preliminary study of soil permeability properties using principal component analysis. This case study was conducted by researchers from Research Center for Limnology in Indonesia. The second case study is researchers on permeability and soil structure for the implementation of sustainable landscape architecture practice, which is conducted by lecturers, research assistants, and students from University of Agriculture Science and Veterinary Medicine in Cluj-Napoca, Romania. So we move to case study number 1. The first point is the introduction. First point is soil permeability measurement is undoubtedly important in carrying out soil water research such as rainfall runoff, modeling, irrigation, water distribution systems. It is also known that acquiring reliable soil permeability data is rather laborious, time-consuming, and costly. The purpose of this study is to identify which soil parameters correspond strongly to soil permeability and propose a preliminary model for permeability prediction. Principal component analysis, which is we call PCA, was applied to 16 parameters analyzed from 37 sites, consists of 91 samples obtained from Batanghari watershed, which is this case study is conducted at Batanghari watershed, Sumatra, Indonesia. So next is background study. Knowledge of soil permeability and its variation is needed in many environmental applications such as for rainfall runoff, modeling, irrigation system, design of the earth dams, and flood management. The higher the permeability of a soil layer, the faster water can infiltrate through to avoid flooding. Laboratory tests could not represent the heterogeneity of soil permeability in the field. The purpose of this study is to identify which soil parameters correspond strongly with soil permeability and propose a preliminary model for permeability prediction. we move on to the materials and methods for case study number 1. First thing we need to know that this study utilized a soil data set sample from May 2015 to August 2016. The soil sample were collected from 37 sites consisting 91 samples in Batanghari watershed, situated in Jambi and West Sumatra province. Collected samples represented soil types and land uses from the upper, middle and lower part of the catchment area. Then the soil samples were examined and several parameters of the soil properties were measured, which are water content, bulk density, particle density, percentage of sand, silt clay, fine clay, porosity, quick drainage, slow drainage, soil moisture retention, organic matter, water availability, and soil permeability itself. So as we can see, the figure 1, map of soil sampling sites in Batanghari watershed, Sumatra Island. So this is where the studies place. Then the figure 1 is the flow diagram for permeability analysis. So then we move to the methodology, which is method that the people that conduct this case study or research. So the method for this research is using principal component analysis, which is PCA that I said before. Perform regression analysis to search the equation for correlation between parameters. In general, the stages of this study are to identify and determine the factors related to the soil permeability value as shown in figure 2, which is this one, figure 2, flow diagram of permeability analysis. So result and discussion. After the researcher do method to find the factor related to the soil permeability value as shown in figure 2, the result and discussion is permeability express the ability of soil to pass water either laterally or horizontally. The rate of permeability, commonly expressed in units of cm per H, is a function of various physical properties of the soil. So as the result, among the 5 primary factors resulting from PCA, which is principal component analysis, bulk density is the only similar parameter taken into account in the soil characteristics model proposed. So that's for case study 1. We move to case study 2. Sustainable landscaping incorporates a variety of practice and have been developed as a response to environmental issues and are used in all phases of landscaping. Bioorientation offers a combination of local stormwater management, improving urban green aesthetic value and facilitating increased polluted water retention function. Okay, then background study for case study number 2. The bioorientation is based on natural principles and on the quality of the soil and use a given area, designed to capture and filter out the water surplus from precipitation through a soil mixture that allows water absorption and at the same time its usage by the existing vegetation. Second point is to establish an important implementation condition of the bioorientation system was approached the issue of permeability and soil structure in 4 different sites in terms of land use in Clash Napoca, which is this research happened in Clash Napoca. Then for the materials and method that the researcher used to this case study is for the determination of the permeability and soil structure in the selected sites were performed 4 geotechnical drilling. Research from Geotechnical point of view aim to establish lithological succession, particle size, distribution, and degree of uniformity, volumic weight, specific density, and soil permeability in the study areas, and the classification of studied soil in the 4 hydrological group. So as we can see in the figure 1, shows the location of geotechnical research work, which is there are 4 types, 4 places. They take first one, figure 1, A, we call it A, geotechnical drilling location in low density residential area, which is this place is the where they do the research. So the figure 2 is geotechnical drilling location in the commercial area, B. So the C and D is geotechnical drilling location in the high density residential area, C, and in the industrial area, D. Residential area, C, and industrial area, D. So for result and discussion from this second case study that we took, after the analysis of texture of on the soil profiles were found large oscillation under the aspect of the 3 categories of particle, so that the depending on their percentage was determined the soil texture class from studied site. Based on the result presented in the table 1, which is this summary of analysis, they determine the following soil type: is clay, dust, sand, sea, commercial area, low density residential area, RDM, high density residential area, and high industrial area. So in this result, we know that the degree of non-uniformity, all the results are in this table summary analysis. Then in the table 2 are presented the result of the classification in the hydrological group of the soil from the 4 systems in which have been made the drillings. So this is table 2, that classification in hydrological group of soil from study site, 4 types of place that they do the research. So the conclusion for case study in case study 2 is the implementation of the bioorientation cells in Clash Napoca, Romania, which is that place, is not only feasible but is also imperative to improve the soil quality and for an efficient management of surface level runoff. So after the analysis, after the result, it is recommended for the construction of bioorientation system to assess carefully the soil structure from the implementation area. Given the fact that there is a variation in soil characteristics and that is some cases in it is necessary to provide the bioorientation system with under drain to achieve the objective of rainwater runoff management. So that's all for case study, topic about case study. Thank you. Assalamualaikum. We move on to the next topic.
Okay, Assalamualaikum and hi, my name is Muhammad IZZUDDIN bin AZMAN. My matric number is CF210257. Okay, the part is discussion, and we will discuss about soil permeability. Okay, soil permeability or hydraulic conductivity is the rate of the flow of water through soil materials, and it is an essential characteristic across a broad spectrum of engineering and earth science disciplines. Geotechnical and civil engineers, hydrogeologists, soil and environmental scientists all use this information for projects such as structural foundation, embankments, earthen dams, flood management, effluent infiltration, and more. It's no surprise that porosity and permeability of soils are related. Soil voids create an easy path for the movement of water, but other factors like hydraulic gradient, soil type, texture, and particle size distribution also affect permeability. Darcy's law, which dictates all results from soil permeability tests, is an equation describing the movement of fluids through a porous medium. This equation defines the coefficient of permeability or hydraulic conductivity of soils, a ratio of fluid velocity through the soil matrix to the hydraulic gradient. Okay, what is Darcy law? Okay, Darcy law is valid for laminar flow only. The discharge velocity is proportional the hydraulic gradient. We can see here the permeability, the Darcy law is based on Darcy experiment, and the equation is Q equal to Ka H1 minus H2 divided by L. Okay, what is the coefficient of permeability? The coefficient of permeability is the velocity in meters or centimeters per second of water through soil. Fine-grained soils such as clays might have values of around 10 to 8 meters per second or lower, or sand and gravel formation could be a 10 to 4 meters per second or higher. The equation for the coefficient is K equal to QL over AH. Okay, how is soil permeability measured? It has two tests for we to measure the permeability. The first test is the constant head test. It refers to an apparatus where the same relative elevation of the top of the water column remains over the sample throughout the test. It is a valid test for soil with a high rate of flow, like sands and gravels, but also some clay soil. And the second test is the falling head test. The falling head test allows the head to decrease as water infiltrates the sample, diminishing the pressure over the course of the test. Falling head methods are generally limited to fine-grained soil. Okay, we will see about the soil permeability test equipment. Okay, the first equipment is the flexible wall permeability cells, also described as STM D5084. Sorry. It is used to measure hydraulic conductivity of soils using several methods. Okay, the second equipment is the constant head permeameters. It is used to measure the coefficient of permeability of non-plastic soils with no more than 10% of particles passing a 75 test sieve. The procedure described in ASTO T215 and is also a withdrawn standard in ASTM D2434. Okay, the third equipment is a constant of falling head permeameters. It is allowed the option of testing granular soils under either constant head or falling head conditions, but do not meet published ASTM or ASTO test method requirement. Okay, the fourth equipment is compaction permeameters. 4 inches or 6 inches soil moisture density compaction mode supply with upper and lower plates fit with valve and ports to function as permeameters. Next, we have the Shelby tube permeameters. It is a kit of component to bolt a permeameter around a section of an undisturbed sample retained in a 3 inches Shelby tube. And the last one, we have a double ring infiltrometers measure soil infiltration rates in the field for geotechnical and environmental applications such as dam and reservoir design or liquid waste and leaching studies. This concern had tests follow a STM D3385 methods and produce optimum result on uniform fine grain and soil. Okay, I think that's all that we can discuss. That's all from me. Thank you.
My name is Muhammad SALLEHUDDIN ISKANDAR bin HISHAMUDIN, and I will be concluding the presentation. On the first chapter, Introduction, we have talked about the definition of permeability, factors of permeability such as water properties and soil properties, along with their subtopics, and also the importance of permeability. On the second chapter, Application, we have chosen slope as a topic, and we have derived slope into two things to talk about. Slope failure factors, which consists of 6 factors. 2 of them are gravitational forces and earthquake forces. And then we have talked about the means of slope protection. Some of the methods to protect slope are geotextile and metallic structures. Moving on to case study, we have studied 2 cases from other researchers. The first case is permeability properties using PCA, which means principal component analysis. In this case study, the researcher has found themselves an equation for permeability using 5 factors they have found in their study. And the second case is about permeability study for bioretention. The researchers of this study has recommended that before we apply bioretention system in a certain places, we assess the soil so that bioretention system we apply will achieve the objective of rainwater runoff management. And the fourth chapter is discussion. In this chapter, we have discussed about the permeability coefficient K along with the testing equipments which we need in studying permeability. And the presentation, this whole presentation and technical report would not have been done without the hard work of our team members such as MUZHAFAR, AKMAL IZZUDDIN, SYAHMI NAZMI, and AGHNIA. I would like to appreciate our viewers and our team members. That's all from me and from this presentation. Thank you.